Hi, welcome to my video on minimum word problems, level 1. And I say level 1 because the word problems could be done in pre-calculus, could be done in grade 11 or 12, depending on where you're doing your math. So let's look at number 1. Find two numbers differ by 12. Find their minimum product. So if two numbers differ by 12, let x be one number, and let's let y be another number. The two numbers are x and y. The two numbers differ by 12, so that means x minus y equals 12. Differ means, to me, subtract. So that means if I take this expression and solve it for y, we move the x over, make it negative, divide by -1, we get y equals x minus 12. So the product, and the product I'm going to call the product P. So product P, the product is x times y. Notice the product is the function of x and y, so if I replace the y with x minus 12, then the product is x squared minus 12x. Now the product is a function of x. Even though the two numbers differ by 12, the product is now x squared minus 12x in terms of, so we can do the derivative, and the derivative of is x squared, derivative of x squared is 2x, derivative of negative 12x is negative 12, and if we make the derivative equal to 0, we get 2x minus 12 equals 0. 2x equals 12 divided by 2x is 6. So when you make your derivative equal to 0, that's finding the point. Again, this is a positive 1, so this is the minimum point on here, because it's like a parabola, which is a square. Parabola is opening downward like this, or sorry, not open. The vertex is down, so the parabola is opening upward as positive. So that means you're going to find the value of x where this vertex, or the minimum product, occurs. So now we have P equals x times x minus 12. So we got x is 6, so 6 into 6 minus 12. So 6 times negative 6, which is negative 36. So 6 is the value, and if you wanted to get the other number, in which we didn't need the other number, what we're looking for, find their minimum product. So by subbing it into here, I only needed the x to sub in to get their minimum product. But if I wanted to, I could have, if I wanted to, did y equals x minus 12, y equals 6 minus 12, so y was negative 6. So the product is x times y, and x is 6, y is negative 6, so I get the same answer. So I had two choices. I could sub the 6 into here and get the product right away, or I can find a y value and then put it in here and get the product. But the minimum product is negative 36. Okay, let's try another one. This one's a little bit more difficult, but that's why I picked it out. A 20 centimeter long string is cut into two pieces. One piece is bent into the shape of a square, the other piece into the shape of a rectangle with the length to width ratio of 3 to 1. Find the minimum sum of their areas. So what we have, if you take it, here's a string like this, and this string is 20 long, and we're going to cut it into two parts, and we're going to call this part that we're going to cut into x, we're going to call this part y. So there's a string 20 centimeters long cut into two pieces. So that means that we have x plus y is 20. And so what we normally see most teachers do, most books do, y equals negative x plus 20, or you could have had y equals 20 minus x. It makes no difference which way you write it down. It comes out to be the same. Now, it forms a square. So x, if x is a square, this is going to form a square. So this piece here is forming a square like this. So that means that the perimeter of the square is 4s. So x equals 4s. So s, the side of the square, is a quarter x. So that means that's 1/4 x, that's 1/4 x, and so on, like that. So that means the area of the square, which is s squared, is 1/4 x being squared. So the area of the square is 1/16 x squared. The other piece is forming into a rectangle, but the sides are in a ratio of 3 to 1. Let's explain. So if you take the y and it's divided like this, so this length here, y, is divided into a rectangle. So the pieces are in a ratio 3 to 1. So that's similar to like a 3x to an x. And the reason I put an x there right now, just for a second, I don't mean, I'm not confusing this x with this x. So I could say, let's go with 3a. Make it 3a to 3a. So the ratio is 3 to 1. So it's 3a to a. So if a was 2, so that would be 2 to 6. 6 to 2 is 3 to 1. If that was a 10, that would be 30 to 10. It'd be 3 to 1. So altogether, 3a and a makes up 4a. So the total distance here is 4a. So that means that one piece, the ratio, one piece is 3/4 and the other one is 1/4. So the ratio is 3 to 1, which means you have a 4. So it's 3a to 4a and a to 4a, so that's 3/4 to 1/4. So that means that the total distance is here. So it's 3/4 of that distance is the length, and 1/4 of the distance is the width. So the area of this piece, which is y, the area is 3/4 of negative x plus 20 times 1/4 of negative x plus 20. So the area is 3/4 times 1/4 is 3/16 of negative x plus 20 times negative x plus 20. Again, the ratio is 3 to 1, so that's 4 in total. So this is 3/4 of this piece, and this is 1/4 of this piece, and there's this area. And if we expand that out, we get 3/16, and we multiply this out or square it, so we get negative x times negative x is x squared. That's a negative 20x, and that's a negative 26. That's a negative 40x. 20 times 20 is 400. When you multiply that, you get 3/16 x squared. When you multiply here, you will get, this is 3/16 times 40. 8 and that goes 2, 8 and that goes 5. So this is 15 over 2x. And 3/16 of 400. 16 goes into 400 20 times, so that's a plus 75. 3 times 25. So this is the area of the square. This is the area of the rectangle. And so the total area T is 1/16 x squared. Add on 3/16 x squared. Make that, there it is. And so we combine that, so the total area is 4/16 x squared, 15 over 2x plus 75. And to make that a little bit easier, 4 over 16, make it 1/4. Now we have the two areas combined, simplified. So that's the total area, and this maximum area is going to occur at what value of x? So that means we have to do t prime, the derivative. The derivative is the slope of the tangent, and it occurs at what value? So 1/4 times 2 is 1/2 x, and 15 over 2 times x is negative 15 over 2. Derivative of 75 is 0. So that means that t prime is equal to 0, or this maximum, the sum of the areas is going to occur. So that means a half x minus 15 over 2 equals 0. Multiply by 2, I get x minus 15. So 2 times a half is 1. 2 times 15 over 2 is 15 with the negative. So x is equal to 15. So this minimum sum of, notice we added the areas, so this is the sum. This is the minimum sum occurs at x is 15. So t equals 1/4 x squared minus 15 over 2x plus 75. So x is 15 squared, 15 over 2 times 15. Now we just, if you have a calculator, you can plug that in, but I'm just going to take my time. 15 squared is 225. 15 times 2 is 225 over 2 plus 75. And so that comes out to be, if you want to keep working it out, you can bring them all over 2, or you can use your calculator. You can go 225 over 4 minus 225 over 2. Okay, and let's go up here. So we can get a common denominator is 4, so that's 225 over 4 minus 450 over 4 plus 75 is 300 over 4. So I multiplied 75 by 4 over 4, multiplied 225 by 2 over 2, and I have 75 over 4, which comes out to be 18 3/4. That's the minimum sum of their areas. When you take this 20 centimeter string and divide it this way, a beautiful problem to work on. A lot of math in here. So I decided to make the problem a good one to do, which is at the end, because this again, these videos could have been done, or these problems could have been done in grade 11 or 12 or in pre-calculus, but they're level 1. There are more max and min word problems coming up later on in my videos. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.